Hello, it's Mr. Claudia here, and today we're going to continue our review of functions by looking at a special type of function, which is composite function. Now, composite is a word that means you've combined two things. So a composite function is a combination of two functions. And the way we usually write a composite function is the fog. Fog at x. Now this is an odd notation, and the way we say it actually is not fog. We say f of g of x. Fog at x essentially means f at g at x. So when we write this notation, we have to know, and I would encourage you to just rewrite it immediately like this. So it means take the function g and sub it into f. Combine these two functions. If you want to think of it visually, remember we use that idea that a function is a black box that transforms x's into something different. So if you look inside the fog box, you'll see it's actually two functions. So in this case, you put in something. So you put in an apple. The g function transforms that apple into a lemon. Then the f function, so you take whatever that output is, put it into the f function. So the lemon goes in, and it comes out as an orange. So you've transformed twice. But if you look at it as a whole, you're putting in an apple and you're getting an orange. This middle step is happening inside. Okay, the composite function is not a super difficult concept. We learn it because it will help us later with a difficult calculus concept. And IB really likes to have questions like this, especially to make sure you understand this notation and you remember how to do these kind of straightforward questions. So, for example, if I have a function f at x is equal to 2x plus 1, and I have a function g at x equals 3 minus 4x, express the following in simplest terms. Fog at x, or f of g at x. So what I told you before, and I encourage you to do, is to rewrite this immediately as f at g at x. That makes it a lot simpler to understand. And now you know what g at x is. It's 3 minus 4x. So I'm going to sub that in. So in prior lessons we had subbed in numbers. Well, today we're subbing in a function. Okay, so now I need to take my f function and take out the x and replace it with 3 minus 4x. So I have 2 times 3 minus 4x plus 1. Well, now this is just a math problem. It's just something where I have to apply the distributive property. So I have 2 times 3, so that's 6 minus 8x plus 1. So I get 7 minus 8x. And that's it. That is f of g at x. So I've combined these two. Remember, if you think about it, I could go through this function, then this function. Or if I want to just go from x to my final value, I would just use this. Right? This is the idea of this whole box. Let's try Goff. Well, Goff is a composite function g of f at x. Again, let's rewrite it immediately into something a little easier to understand. So this is the same sort of question, except I'm going backwards. So I'm going to sub f, which is 2x plus 1. I'm going to sub 2x plus 1 into g. So now I take g, I'm going to write it, but I'm going to replace the x's with 2x plus 1. Again, now this is just a distributive property question. Be careful with distributive property. There's a negative 4 here. So I end up with 3 minus 8x minus 4. So I end up with negative 1 minus 8x. What do we see? These two are not the same thing. So that's one important point. In general, f at g of x does not equal g at f of x. Okay, so now that we have that idea, let's try doing a numerical example. Given f of x is equal to 6x minus 5 and g of x is equal to x squared plus x, determine gof at -1. Whoa, look at all the different notations here. Remember, I told you that IB likes to make sure you understand your notation. And IB is an international program, so they're going to give you notations from different places in the world. We very rarely see this in North America or in Canadian high school, but this is another way of writing a function. And really, without me even telling you, you would probably guess that this is what it means. So that's one thing to understand. The other is that we're looking for gof, not gof at x or g of f of x, but g of x at -1. So there's a few ways you could do this. Let's look at solution 1 over here. I'm going to find g of f at x first, like I did in the question above, and then I'm going to sub in -1. So what do I have to do here? Okay, so g of f at x. I don't like that notation. I'm going to rewrite it to something that I understand a bit better. Okay, now I'm going to sub in f, which is 6x minus 5. Okay, now I want you to take my g function, and I have to replace all the x's with 6x minus 5. So I end up with bracket 6x minus 5 squared plus bracket 6x minus 5. Okay, hopefully you remember that 6x minus 5 squared, this is 6x minus 5 times 6x minus 5. In case you're a little rusty. And now to simplify this, well, I have to use my FOIL method, right? I have to multiply the 6x by 6x, 6x minus 5 by 6x, and minus 5 by minus 5. So just a little bit getting used to doing this again. We end up with 36x squared minus 30x minus 30x again, and minus 5 is plus 25. And because this is a plus, this just kind of melts away. Now I'm going to collect my like terms, so I end up with 36x squared minus 60, so I have minus 54x, and then plus 20. Okay, so that is my expression for g of f at x. Now the question was asking for g at f of -1. So I'm going to sub that into my expression I just determined. And that gives me -1 times -1 is 1, so this is 36. This makes a positive, and plus 20. We should be able to do this in our head, right? That's 60, 70, 80, 90, plus 20 is 110. So there's my numerical answer for a numerical question. Now, the other way of solving this, so solution 2, we'll write over here, would be to find f at -1 and then sub into g at x. Oops. So, for example, first of all, let's rewrite this. G at f of x. Let's rewrite this in something that makes more sense to me. So the question was actually asking us for g at f at -1. So this is essentially going to be g at f at -1. So for this alternative method, I'm going to find what f at -1 is, which is some number, and then I'm going to sub that into g. So let's figure out what that number is. So I'll just do it in a little off to the side here. F at -1 is taking the f function, so 6, and I'm going to replace all the x's with -1. So I end up with -6 minus 5. That gives me -11. So there's my kind of side work. So g at f at -1 is going to be g at -11. Well, now I just have to go to my g function and replace all the x's with -1. So I have -11 squared plus -11. So I end up with 11 times 11, which is 121, minus 11, this gives me 110. So two different solutions that give me the same answer. Which one do you like? I find this one to be very logical, as step by step, but you can see the algebra got a little bit hairy in the middle there, because you end up finding an expression, general case expression that works for anything. This tends to be a little quicker, but maybe is a little less intuitive. But this solution is useful for, especially when we get into calculus, you'll see some questions where this sort of understanding is really valuable. So hopefully you understand this, but feel free to use whatever is effective for you. Your homework for this short little section is page 15, number 1, 2, every other, and number 3 to 6. Good luck, and we'll see you next time.